In this video, we'll talk about the extraction process in the lab. So how do we do it actually in the lab? So in the first step, we add the mixture to the separatory funnel. You can use either a funnel or you can use without it. It's up to you. Basically, the separatory funnel has to be supported using this ring clamp and on this stand. The second step is that you have to add water and the organic solvent to the separatory funnel and make sure to see the two layers. This third step is that you have to close the separatory funnel and you have to shake it. Usually this is the best way to hold the separatory funnel, so your hand should support the stopcock here to prevent it from moving out. And then after shaking it for some time, you make sure to open the vent which is here so that the pressure goes out. Usually when you shake your solvents, some of these solvents, because of shaking, will transform into gas and the pressure will build up here. So it's always better to hold your separatory funnel in this way, open this tab, so that those gases can go out. If you don't do this, and if the amount of pressure is very high, then either the separatory funnel may break or this stopper which is closing it may go out. So it's always better to open the vent to reduce the pressure. Once you're done, you have to open the stopper and let the solution reach equilibrium. So sometimes you have to wait until you can see very clearly that you have two separate layers. Now sometimes emulsions may appear, and when I say emulsions, this is what I mean by emulsions. So instead of having like a very clearly two layers, as you can see here, you can see that in this figure here, in this figure here, or in this figure here, that actually the two layers are not completely separated, and still some particles of the compound are suspended between the top and the bottom layers. Usually this happens if you have a basic solution. So whenever you don't have a clear separation, this is called emulsion. There are ways to avoid emulsions. First of all, to avoid emulsions, usually try to shake the separatory funnel slowly. However, if you ended up having emulsions and you want to get rid of these emulsions, one of the things that you can do is that you have to swirl the funnel. So try to move it slowly in a circular way, and this is one way of breaking suspensions and having clear separate layers. The second option is shaking the emulsion with a stirring rod. So put a stirring rod inside the separatory funnel, try to stir and try to move the two layers, and sometimes this will work. If it didn't work, then we add a salt. Usually in the lab you may have a concentrated solution of water and NaCl. You add a little bit of this to your separatory funnel. This is going to be an aqueous layer which is highly polar due to the presence of NaCl, and this may help in breaking emulsions. So if emulsions occur, these are the ways that you can do in the lab to get clear layers. Now, once you have clear separate layers, you have to drain them into the Erlenmeyer flask. So you have to open the tap and let one of the layers go down. You collect it in an Erlenmeyer flask. If needed, you have to repeat the extraction multiple times, as I said before, because usually multiple extraction is better than single extraction. So always, whenever you perform the first extraction, you drain your aqueous layer, which is usually, not always, the bottom layer. You put it in an Erlenmeyer flask, and then you separate the organic layer into a different flask. Later on, you put the aqueous layer back in the separatory funnel and you repeat the whole process again. Once you collect all the fractions in one flask, you have to add something which is called the dehydrating agent. Now, your organic solvent may have captured some water molecules, and you want to get rid of these water molecules. So what you can do is that you have to add something which is called a dehydrating agent, which is a compound that can absorb water, such as sodium sulfate. This is sodium sulfate. Or you can use calcium chloride or magnesium sulfate. All these compounds are well known to absorb water. So once you add them to the organic layer, you shake the beaker a little bit, and you will notice that your compound your solution is actually clear right now, because water molecules are not present in the organic layer anymore. So these dehydrating agents absorb water, so they transform, for example, MgSO4. It can absorb 7 water molecules, and it becomes with this molecular formula. Once you are done, you can either separate these. So these compounds, which are the dehydrating agents, usually they look like salts. So when you add them to the bottom of your beaker, and after doing the process, you will notice that they are forming a solid here. So to separate your compound, which is present in the solvent, from these salts, you can either use decantation, so just pour the liquid and leave the solid behind, or sometimes you can use filtration, vacuum filtration, to rapidly do the process and avoid losing your compound. Once you are done, you have the solvent now. This is the organic solvent, which contains your compound. So this solvent contains your compound, and you want to get rid of the solvent, so you can evaporate it using rotary evaporator, which is this machine, or you can just use simple distillation to remove the solvent and keep your compound. In the remaining part of this video, we'll talk about the actual experiment, which is the extraction of caffeine from tea leaves. So tea leaves, they contain a different compounds such as caffeine, tannins, which are all these compounds, cellulose, chlorophyll. So we have a lot of compounds in tea leaves. Our aim is to separate caffeine from all these other compounds. We are going to use, to do this process, we are going to use solid liquid extraction and liquid extraction. Solid liquid extraction will extract all the compounds from the tea leaves, and then in liquid extraction, we are going to separate caffeine from the other compounds. So how are we going to do this? Later on, once we isolate caffeine, we are going to recrystallize it from toluene in order to get pure caffeine. So these are the 3 steps that we are going to do. So let's start with the solid liquid extraction process. So we are going to add the tea bags to boil distilled water, and this is a solid liquid extraction where our compounds will be extracted from the solid state into the liquid state. The color of the solution will become brown, and we already know this. Whenever we put tea bags in hot water, we can notice that the color changes into brown, and this is due to the presence of tannins. So these tannins, which I showed you, showed the structure of them in the last slide, they are actually responsible for giving the brown color for tea. Now, once we're done, we add a few drops of NaOH. And what is going NaOH do is going to do the following. NaOH, which is a base, is going to deprotonate the alcohol groups, which are here. The alcohol groups. So adding NaOH will deprotonate tannins, and it's going to convert them into O-. So remember, anything which has a minus or positive charge is actually highly polar. So this is going to be a more polar compound, and this is going to increase its water solubility. Caffeine doesn't have this highly acidic hydrogen. That's why caffeine doesn't react with the base. So remember, now what we are doing right now is actually acid-base extraction. So we added base to our compound to change its water solubility, to make it more water soluble. This compound have low water solubility. So what happens next? In the liquid extraction, we add dichloromethane. Dichloromethane will form 2 layers with water. So this is dichloromethane. Remember, dichloromethane is a halogenated organic solvent, so it's going to form be the bottom layer. The aqueous layer will be the top one. So the top or the upper layer, which is brown, it contains tannins. Remember that tannins moved to this layer because they were deprotonated using NaOH, so they became more polar, so they moved to the polar aqueous layer. Caffeine has very low solubility in water compared to its solubility in dichloromethane. That's why caffeine will go to the organic layer. And this is, again, this is what we talk. This is the principle of extraction. Remember, our compound caffeine was initially here, and it was mixed with tannins and all other compounds. When I added the base deprotonated the tannins. They became more polar. Because they are more polar, they will stay in the aqueous layer. Caffeine has higher solubility in dichloromethane, so it decides to go down. And now caffeine is in the bottom layer, all the other compounds in the aqueous layer, and this is how we can separate them. So we collect the organic layer, and we use magnesium sulfate, which is a dehydrating agent. Remember, it's a salt, it's a white salt where you add it to the mixture to remove the excess water which is present in the dichloromethane layer. Once you are done, we just decant the solution. So basically just pour the solvent, leave the solid behind. Once you are done, use distillation to remove the solvent and collect caffeine. Now it's very important to be careful not to evaporate to dryness, because the distillation setup may explode, and also because caffeine might sublime. Sublime means it will go from the solid state into a liquid state. So always make sure to have a gentle heating and avoid heating to dryness. Once you also during distillation, make sure that this collection flask, so basically this is a condenser and its DCM is moving through the condenser and put here. Put this in an ice bath, because dichloromethane have a very low boiling point. So if you don't put it in an ice bath, it may evaporate and it's actually toxic. So it's always better to put it in an ice bath so that the collected DCM doesn't evaporate anymore. Once we're done, we have collected caffeine, but this caffeine is not pure. It may have some impurities. Remember from the previous experiments that we use recrystallization to purify solids. So we are going to dissolve it in a hot toluene. Toluene is an organic solvent. So we dissolve it in a hot toluene. Once it dissolves completely, then we let it cool down, let it crystallize, and after crystallization, we do the filtration process to collect caffeine. Once it is dry, we weigh it, and we should obtain after recrystallization these like shiny white crystals, which tells us that we have caffeine, we have collected pure caffeine. Now, of course, if you want to know whether your caffeine is pure or not, one of the things that you can do is do the melting point test. So if you do the melting point test and you get sharp melting points, this means that your caffeine is pure. If the caffeine sample melted over a wide range, this means that your compound or your caffeine is not pure and it needs to be recrystallized one more time.